Hello class, and today we are doing the Chapter 5 final review. We actually went over it a little bit before because I accidentally went too far since you guys were doing so well, and we managed to cover 2 entire chapters in our Zoom, and so we went on to the 3rd. Now, just as a quick review, an absolute value, any number inside the absolute value always comes out what? So I got Hannah and Izzy, Melanie, they all tell me that yes, when it comes out, it is positive. So when something comes out of an absolute value, it's always positive. But sometimes there's an exception to that rule. And now we're thinking, oh my god, how can something always be positive and now only sometimes? Well, we're about to see. What's the answer to this first one right here at the top? What's the answer to that first one? Excellent. So everybody so far has told me it is 8. Yes. Now, what about the answer to this one? That one's already got a positive 8 in there. So I'm going to make it like a negative 8, right? Because, you know, that's how it works, right? No, it's still, as you guys are saying, 8. Yes, it's still 8 no matter what's inside of our absolute value. The number always comes out positive. Awesome. So that means this one's 8 and that one's 8 too, right? So am I having a problem here? Izzy, why is that negative absolute value 8 not negative? We just learned that things are positive when they're absolute value.
It's negative because the negative is outside, but the 8 is inside the positive. Yeah.
Excellent. Yes. So the 8 is outside, and the negative is outside, and the 8 is inside. So sure, what came on the inside still ends up being positive, but this is basically like multiplication. These are basically acting like parentheses, the absolute values. And so if we saw something outside the outside the parentheses, it's also multiplication. So this is a negative being multiplied afterwards. So it becomes negative 8. So then what's the answer to the last one then? Now I've got a negative 8 before I know that a negative and a negative make a positive. But once again, we've got these thick absolute value bars that we can't necessarily, get into. So what would the answer to negative absolute value, negative 8 be? Yes, for those who answered, it is still negative 8. So if there's nothing on the outside here, then it'll come out positive. If there's a positive sign on the outside, doesn't even matter, it'll come out positive still. If there's a negative side, then this part comes out negative regardless of what's on the inside, because the inside will come out positive and then it'll automatically become negative. So that's literally exactly how that goes. Here, we've got our graph. A graph is made up of 4 quadrants. They are called quadrants because there are 4 of them, and quad means 4. Now, in this quadrant, we've got positive for our x and y's, and we've got negative positive for our x and y's, negative for our x and y's, and positive negative for our x and y's. We went over this last time, but what is this axis right here? What is that horizontal axis? Which one? Yes, we know it's X, and again, just like I did in that last video, it's because, look, it looks like a dead man. Boop, that's his tongue. So I remember that it's X because it looks like someone who's dead. X. So thus, the other one is Y. And I remember it's Y because, look, it's got that vertical stick just like this vertical line. So now we got to figure out our quadrants. What quadrant is that one? We're just going to start easy, the one that's right here, positive. What quadrant is that one? Excellent. So you guys know it's quadrant 1. Now, I'm going to write B, C, you can't even see that, C, and D. And I want you guys to tell me which one's quadrant 2. Which one is quadrant 2? Yeah, so quadrant 2, even though you're thinking it might be going down, it's actually there to the side. As such, which one's quadrant 3? So now we're going to think about it. Which one's quadrant 3? It is D right there. And then lastly, our last quad, because once again we have 4 of them, is there. We go around counterclockwise in this case. We go around counterclockwise. And then what we know here, though, is that this upper half of our graph, the y's are positive, and this lower half, the y's are negative because we're going down. So when you go down the ladder, you're going negative. Then this part here, our x's are positive, and on the other side, our x's are negative. That is seen here in these pieces right here. And our graphs, when we write them, when we're filling out a point in our graph, how do we fill it out? Is it x comma y or y comma x? Excellent. So as Ani, Fernando, Sophia, Dominic, Izzy, and Hannah, Nathan, and Melanie, all of you guys are saying it is x comma y. I remember this because it is alphabetical order. X comes before Y in the alphabet, so X comes before Y when we're doing graphing. So, if I was doing that then, what about if I was trying to flip something across the axis? So, we learned that really quick. First things first, I want us to figure out what is this plot point, okay? So what is this plot point right here? What's the value of that plot point? Assuming that each box equals 1, what's the value of that plot point? Perfect. So as you guys see, it's 4, 3. We go over 1, 2, 3, 4, and we go up 1, 2, 3. So now I want to do something. I want to cross it about the x-axis, and I want to cross it about the y-axis. So, I've got these 4 spots here, okay? I've got these 4 spots, and again, I'm going to title these spots just like I did before. A, I'm going to call you C, oops, last time I called it B, that makes more sense. C, B, and D. So, if I was to reflect this point right here, that 4, 3, across about the x-axis, which that one's our x, which point would it be? Which point would it become? Is it going to be point B, point C, or point D when I flip that or mirror it across the y or across the x-axis? Izzy, what do you think the answer is?
C.
And why do you think it's C?
Because we're reflecting across the x, right?
Yeah,
or
flipping across the x.
Okay. So the x, if you were folding a book and you were folding it like
if we were folding it about the x.
Like this, like.
You are completely correct. She is exactly right, and that is a great logistics. If I was to basically fold my graph at the x-axis, if I had a piece of paper and I creased it at that x and went boop and folded it, those are the 2 dots that would touch. Those are where it would touch. What are the point values of C then? I'm guessing that it's that same. 4, 3, right? Because, I just reflected it, so it didn't change. Nothing changed, right? It's just reflected. So, happy, la, 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 let's move on, right? Wrong. It is not that. We cannot have 2 points on the same graph that are not in the same position that have the same values. They're kind of like fingerprints. As Sophia put, this graph has positive, negative, which is a great hint because just by knowing that, I know my 4 will stay positive and my 3 becomes a negative, just as Nathan wrote. Exactly. Which one of these would be reflecting point A, right there, across the y-axis, or about the y-axis? So think about it just like Izzy mentioned before. If we creased it at that y and folded it, which point is going to be about the y? Yes, I got 3 people who answered. I got Izzy, Nathan, Emmett. Thank you guys. And it is B. So what is the value of B then? I see this other one was 4, -3, right? So what is that value? Yes, so we see it's now -4, 3. We're still up above that middle ground, above our origin. This little center part here is indeed, as I forgot to say, called the origin. And that's basically because everything originates from there. And so we're above our origin, which means it's positive for the y's. If we're below our origin, it means we're negative for the y's. We're to the right of our origin, it's positive for the x. We're to the left of our origin, and it's negative for the x. As such, let's say that I rotated B around the x-axis. The only thing that's left right here is that. What is the value of that point right there, of point D? Excellent, Emmett and Nathan. It is -4, -3. Just by looking back at this past chart and remembering these 4 sections will help you so greatly. And or remembering about the above the origin, below the origin, and as people had put, the origin is exactly 0, 0, because it has not moved at all. We originate at 0. When we are born, we are 0 years old. You know, we have done 0 things in our livelong life. Now, let's think about this next problem that I want to bring to our attention. We're going to be dealing with repeating and terminating decimals. So last thing we have is this game I'd like to call terminating or repeating. Da 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 da. So we're going to look and determine when we do division of fractions, if we're getting something that terminates, if that decimal will end, or if we get something that repeats where it doesn't end. So as we know, terminate means end, like exterminate. We want to end the bugs, I'm terminating this meeting, I'm ending this meeting, the end of your terms, that is the end of that. Then repeating. If you don't know what repeating means, I can't really help you there because it means it keeps going on and on and on and on and on. So I'm going to give you a couple of math things to do, and you are going to solve them, and you are going to tell me if it is terminating or if it is repeating. Okay? So now when we divide fractions, how do we do that? When we're dividing fractions, we'll do some long division. And what goes inside our house again? What goes inside our house? Even though I covered this Tuesday, this is one of the hardest things, so I'll just go quickly with this so that we can go. Inside the house is our numerator. Outside the house is our denominator. AKA the numerator is our dividend and the outside is our divisor. And we're trying to solve for our quotient. When our denominator is bigger than our numerator, we know that our fraction is less than 1. So we do a 0 point and a 0.0. So then we go over, how many times does 7 go into 50? It goes in 7 times. That's 49. We subtract, we get 1. We bring down another 0. It goes in 1 time. That's 7. We subtract, it's 3. Keep bringing down zeros, you guys. This time it goes in 4 times. That's 28. We get 2. Bring down another 0. 20, it goes in 2 times. That's 14. We get a 6. Bring down another 0. It goes in 8 times, which is 56, which we get 4. We bring down another 0. It goes into 40, a total of 5 times, which is 35. We subtract, we get a 5. We bring down yet another 0. But wait! Here, right up here, we have a 50. And right down here, we have a 50. What that tells us is that since a number in our division is repeating, that this whole thing right here is repeating. And when we repeat, we put a nice little line on the top to show those numbers are repeating forever. All of those numbers repeat forever. What about something like this? 1/4. If I did 1/4, I do that. 1/4. Obviously, we know it cannot go in. 0.0. Then 4 goes into 10 2 times. That's 8. We get 2. Bring down a 0. 4 goes into 20 5 times. That's 20. So we get 0. So at this point, is this a terminating decimal or is it a repeating decimal? What do we think? I see people saying things. Terminating. Yes, because it ends. There is no further. There is no further. -5 divided by 6. A lot of you get thrown off by that. Here's the thing. We don't need to care about the negative. All we know is that's the answer is going to be negative. So just ignore it and treat it as it is. So it's going to be -0 point. This is going to be 5.0. And then on the outside, we got 6. The negative does not impact our problem at all. We just know that our answer is going to be negative. So just put the negative up top and there you go. Bing, bang, boom. 6 goes into 50, a total of 8 times. And that's 48. We subtract, we get 2. Bring down a 0, 20. 6 goes into 20 3 times. That's 18. We subtract, we bring down a 2. Hey, we already have something. So that's going to keep repeating forever, right? So that means here that I'm going to put a line over both of these, right? Awesome. So it's going to be -0.83 forever. Wait, is he saying no? What did I do wrong? We found out that it's repeating. Oh, Fernando says only the 3. Yes. So it is possible for only part of something to be repeating. Nathan says we put it just over the 3 because the 3 is the only part that keeps repeating. That 8 only happened once. So it's completely possible to have something where all the numbers repeat, where none of the numbers repeat, and where some of the numbers repeat. So that's a nice review of chapter 5 and a little bit back into chapter 4. That's honestly it.